Welcome to Vision Plus and welcome back to S.4 Mathematics. Today we are going to look at one of the fundamentals of mathematics, and that is the calculus. Under calculus, we look at two main concepts. One, we look at differentiation. Two, we look at integration. Differentiation is the opposite of integration, as well as integration is the opposite of differentiation. So we are going to begin with differentiation. And under differentiation, we shall look at the following. One, shall look at method 1, that is for differentiating given expressions or functions. And in method 1, we shall deal with coefficients and powers of given terms. That is 1. 2, in method 2 that we shall use to differentiate given expressions or functions, method 2 we shall be differentiating from the first principles. We shall see how we can differentiate from first principles. Both methods, that is method 1 and method 2, give us the same answers. And the third thing that we shall look at here is that we shall look at gradients of a curve at a given point. We shall look at how we can get gradient of a curve at a given point. 4, we shall look at normals and tangents. So we shall look at tangents and normals to the curve. When we look at tangents and normals to the curve, we shall look at their gradients and their equations. That is the equation of the normal and the equation of the tangent. And then number 5, we shall look at stationary points. Stationary points of a curve. And in other words, we call stationary points turning points of the curve. And under that, we shall look at the maximum point of the curve. We shall look at maximum points. We shall look at minimum points, and then we shall look at points of inflection. After looking at stationary points, then we shall go on to look at the nature of stationary points. But 5 and 6 are together. They are closely related. They are very, very closely related. And now we shall look at 7. We shall look at application. We shall look at application of differentiation. You can say differentiation or differentiation. applications of differentiation to kinematics. Remember, kinematics is concerned with motion. This is a sort of motion. And under this application, one, we shall look at calculation of velocity. We shall look at calculation of acceleration. So these are the main things that we are going to cover under differentiation. For now, I'm not going to quote what we shall cover in integration. And as we go to integration, I will list what we are going to cover. And if you look here closely, I have quoted only two methods of differentiation, but we have very many other techniques. We have other techniques of differentiation. One, we have what we call product rule. We have what we call quotient rule. Quotient is division. And then we have what we call chain rule, among others. There are many. Now, when we are looking at basic mathematics, we do not go deeper into all the techniques of differentiation. Okay? These two techniques or these two methods are the ones that are highlighted in the books that we are using. So we don't go deeper with other techniques. Also here, we shall be looking at simple functions and simple curves. We shall not look at curves like sine curves. We shall not look at cosine curves or even tan curves, tangent. And also, we shall not look at exponential curves. We shall not look at exponential curves. Okay? And even there are some logarithmic curves, logarithmic functions that we shall not look at. What we shall look at basically are simple curves like quadratic curves and curves of higher degrees like 3 and 4. We are not going to sketch even these curves in this case. So basically, I have not defined for you what differentiation means. Differentiation. Differentiation in its essence is just a way of finding derivatives. To find derivatives of functions and or curves. That is what we do when we are looking at differentiation. We find derivatives. Now someone is asking, what is a derivative? A derivative is the instantaneous rate of change. It is a sort of rate of change of a function. It is an instantaneous rate of change of a function with respect to one of its variables. Okay, it is the instantaneous rate of change of a function with respect to one of its variables. In other words, we are saying a derivative is equivalent it is equivalent to the tangent line of a function at a given point, at a given point. We can just say at a point. That is what a derivative is. So differentiation is simply a way of getting derivatives of functions or curves or expression. And a derivative is simply the instantaneous rate of change of a function of an expression, okay, with respect to one of its variables. And we are saying it is equivalent, okay, to the tangent line at a given point of that function. So this is the overview of what we are going to cover under differentiation. So in the next class, we are going to begin with method 1. That is, how can we deal with powers and coefficients to differentiate a given function or a given curve or a given expression, so that we find the derivative of that given function.